So now we are back to a new lesson, lesson 9.1. We're talking about the geometrical representation of vectors. So guys, every time you need to define a vector, you need to check those three components of the vector. So first of all, we need to check the direction of the vector. When I say direction, it means I want to see on which line these vectors are lying. So the vectors could be both on the same line or parallel. So I need to be careful that when I talk about direction, it means I'm just checking on which line the vector is. The sense, it means I'm going from left to right or right to left. So I'll just give you a small example about those two. When I talk about the highway, on the highway, there is some cars sometimes going this way and the other are going in the opposite way. If I want to talk about the direction, those cars they have the same direction, even if one is going from left to right, the other from right to left, but they have opposite sense. Now, when I talk about the magnitude, I am talking about the length of the segment or the length of the car. So to find the magnitude of any vector, I need to use the distance formula if I have the component. And I have those four methods to write the length. So you can see it this way, or this way, or this way. So guys, when I need to compare any vectors, they should have first of all same direction. If the vectors they don't have the same direction, no need to continue. If one is going like this, the other going like this, no need to continue to compare, even if they have the same magnitude. So they have first to need you need to have the same direction. It means they need to be parallel or they need to lie on the same line. Then after we compare the direction, we're gonna compare the sense. We're gonna see if it's from left to right or right to left, and after the magnitude. So when two vectors are equal, we can directly deduce that it's a it's a parallelogram. So if I look at this figure, if I say AB is equal to DC, what does it mean? When I say two equal vectors, I can deduce 2 points. I can deduce that they are parallel and they are equal. So, and you know that to prove a parallelogram, it's enough to prove that you have a pair of parallel and equal sides. So, equal vectors helps me to prove that I have a parallelogram. So what are the operations that I will use with the vectors? We have two rules for the vectors. We have first the triangle law, or also we say consecutive vectors. So if I am at A, guys, and you went to B, and then from B you went to C, where you will be in the end? At C. It means you will move from A to C. Let's say I'm standing here and I ask someone to close his eyes, okay? And I did like this, and then I stand here and I told him, open your eye, what you will see? He will say, okay, you moved from A to C. He cannot guess if I really passed by B and then moved to another point. So when I have consecutive vectors, it means when I end with a letter and I start with this letter, so directly we say it's a triangle law. You can integrate any letter. You can say AB plus BC plus CF plus FM, so it's AM. So we can also use this property, guys, to prove that those three vectors form a triangle. So later on in the application, you will see that sometimes I will ask you, show that those three vectors form a triangle. So you need to try to find or to write a relation or to prove that the sum of one of those two vectors gives me the third one. The second law of the operations with vectors is the parallelogram rule. The parallelogram rule, it's when I have the same origin. So if you look at this one, I have A here. AB plus AC gives me a new point, and this new point will form a parallelogram with the other two vectors. How can I prove that? It's very simple. If I have AB plus AC, all what I need to do is to change AC by a vector that starts with B. So which vector is equal to AC? It's BD. So instead of AC, I can write BD, guys. And what is AB plus BD? It's AD. So even if you forgot the parallelogram rule, you can easily do that. Try to change it with another vector, but it's a rule. When I have the same origin, the sum of those two vectors will be the same origin plus the fourth point of the parallelogram. What does it mean linear combination of vectors? So if A and B are two non-collinear vectors, it means they are not on the same line or are not parallel. We say that, sorry guys, okay, we say that a linear combination of those two vectors is a new vector C. So if I can write a new vector C as alpha A plus beta B. For example, if I can write a vector C 2A plus 3B, I can say that those vectors form a linear combination. And why do we use this one? We need to use it to prove that you have coplanar vectors. What does mean coplanar vectors? That those vectors are in the same plane. So if they are in the same plane, they form a combination, linear combination. Let's do an example, guys, to see how we can do that. So for example, if I will give you this is my vector A and this is another vector B, you need to draw the following linear combination. You need to draw the third vector that verifies 3A plus 2B. First, this is the vector A, so I need to draw 3A. So I need to do the same. So I will fix a point of start. I'm starting from here, and from this one I'm gonna draw 3A parallel to A here as I'm sliding this one here because it's 3A. When I finish, I start to draw 2B. Parallel to this one, I have 2B. So I start from here and I end from here. So what's going to be the sum of those two vectors? This is the third vector. Exactly the same for the second one. I said half A. This is A, half of it. So I'm going to draw a vector parallel to and half of it, like it's here, the red one. Minus 2 over 3b. First, I will divide b in three pieces, and I'm gonna take 2 out of the 3, for example, this one here. But be careful, there is a minus here, so I will not draw it this way, I will draw it this way. And then this is my start, this is my end. So this vector, the blue one, will be the linear combination of those two vectors. Now, what does it mean, collinear vectors, and how do we prove collinear vectors? Guys, collinear vectors means either the vectors are parallel like this one, either the vectors are they lie on the same line. So when I say collinear vector, it doesn't mean that it's on the same line. They can be either parallel or on the same line. But when they are collinear, you can write a relation because look, it's AB, for example, is equal here half CD, or CD is equal to AB, even like this. So when you can write the relation between those two vectors, that AB is equal a constant times the second vector, it means those vectors are collinear. But also this property, the collinear vector, helps me sometimes to prove collinear points. Because if two vectors are collinear, it means they are either parallel or on the same line. But if those vectors have a common point, they cannot be parallel. For example, here AB is equal, let's say, half BC in this figure. If I said draw AB equal half BC, you cannot draw BC here from here because you gonna need to continue from this one. And when I say equal, it means they should be either parallel or on the same line. I cannot draw from B a parallel line to AB. So when two vectors are collinear and they have a common point, it means I can deduce directly that I have collinear points. So like here, I have AB is equal half BC. So what does it mean? This relation gives me that AB and BC are either parallel or on the same line. But since they have a common point, they cannot be parallel. So they are on the same line. It means AB and C are collinear. Let's move to some example, the last example here. Given ABC a triangle, I have M midpoint of AC and I have N midpoint of BC. I need to prove that MN is parallel to AB and then MN is equal half AB. So to be able to prove that those two are parallel, I need to write a relation between MN and AB. So I should think about how do we write MN is equal to alpha AB. So the first thing that I need to think about is to decompose MN in the sum of two vectors that let me reach AB. So how did I think about that? So I decomposed MN to MC plus C. And you're going to tell me, Miss, why you didn't do MA, for example, here, plus AN? You can do that, but later on, AN will not lead you to AB. So you're going to continue changing and changing. So I chose to put MC and NC because MC and NC can be related to AC and BC, and I have the letter A and B. So what is vector MC related to AC? MC is half AC. And what is the vector CN related to CB? It's half CB. And now I have half as a common factor. If you factorize by half, you will have AC plus CB. And what is AC plus CB? Consecutive vector, it's AB. So I have MM is equal to half AB. What does it mean? It means those two vectors are parallel and not just parallel. MN is half the distance of AB. So I proved also the second question that MN is equal to half AB. But if you remember this one, this rule, we took it in grade 9. We call it the midline or the mid segment or the midpoint theorem in a triangle. This is the proving of that. In grade 9, we don't see it like this. But this, how do we prove why MN is parallel to AB and why it's equal to half of it? And also in the class, we're going to prove the one of the trapezoid, why the midline is parallel to the other two bases and equal to this to half of their sum. That's it, guys. If you didn't get it, watch again the video, and sure we'll do more application in the class and you will get it.